All right, let's check on that Pro Micro. Did that QFN get flipped? How the hell does that happen? Hey, this is Helmet with Lord's Boards. Have you ever submitted a board and found that your fab house may reject it for some DFM reason? Or have you ever received boards in your hand and seen some glaring mistake that you should have caught but didn't? Let's make sure that never happens again. Or at least happens less often. In this video, we'll set up ERC and DRC rules, then automate them with a KiCad Jobset, a new feature in KiCad 9. Jobsets, just like the outJob feature in Altium, allow you to export repeatably from your KiCad source files. It prevents the issue you just saw with a flipped QFN making it all the way to production. Unfortunately, not the most expensive mistake I've ever made. Our frame story here is this STM32U585 Pro Micro. There's not a whole lot going on here. It's really just that STM32 required passives, a regulator, protection IC, and then a stemma port. Taking a look at the board, it's an 8-layer board from JLC PCB with castellated edges and a couple of buttons. Not a ton going on here, which makes it a little bit more embarrassing that I managed to flip the QFN. Let's get a reenactment going here. Yep, that's not going to solder right. I think a lot of people are more familiar with the DRC rules that you can run on your PCB itself, but it's also useful to run ERC rules, which can be found here under Inspect, Electrical Rules Checker. Let's go ahead and run and see what all we get on this board. So you see some of these doesn't match copy and library. That's not that big a deal. Input power not driven by output pins. You might have to address that. Label not connected to anything. Okay, can remove that. You'll see all of these. Some of them you can exclude. So I'll go back and fix this, but just to demonstrate, if you right click on one of the violations, you can click exclude this violation or exclude with comments. We'll say test exclusion, please ignore. There we go. So we'll fix those errors here in just a moment, but this is kind of the baseline thing you want to do as soon as you finish your schematic, or if you change anything in your schematic. It'll catch errors that you might have missed. Some of them are going to be things that are mistakes in the symbol. Maybe it comes from an external library or your KiCad library, like that out power pin and in power pin. But some of them can be very real logical errors that you need to catch in your board design. To modify your ERC rules, you'll go to Schematic Setup, Electrical Rules, and then you can modify the violation severity or your pin conflicts map. What that means is if you were to put like a power output pin on an output pin, you would see an error or a warning, right? You can change this as you see fit. And you can change the severity of different warnings. So let's say we want to do a lot of spice simulation. We'll go over here and change this to a warning, something like that. So I'll go ahead and clean up the errors we see in this and get us to a good baseline of 0 errors, which is what you should always aim for when you are designing something in KiCad. So now with those errors cleaned up, when we run the electrical rules checker, we'll see 0 errors, 3 exclusions, and then some ignored tests. The electrical rules don't really have as much to modify since you don't have hard constraints, and it's hard to catch all logical errors with the ERC. So in general, make sure you do double check your boards before you start layout. And of course, as you're laying things out, you will have to do some give and take, some dance between the PCB layout and the schematic as you find some routing of pins doesn't work or you find a more ideal routing of pins. So be sure to keep them open together. But if you make a change anywhere in the schematic, always go to your ERC, give it a quick run just to make sure things aren't broken. Now we will move on to the DRC rules for your actual board layout. It's accessed in a very similar place. So you'll go to your board setup, design rules, and here you set your constraints, predefined sizes. You can modify a lot of things for your teardrop connections if you choose to turn those on. Some things more critical for differential pair routing, net classes, which are used to set specific trace widths for a certain kind of trace. custom rules you can set here. Some board houses will actually provide you a list of custom rules. I personally prefer to edit them here in the constraints, at least to begin with. If I have something wacky, I may go and lean on whatever the board house provides. JLC, for example, does provide some of these. And much like the schematic ERC, the DRC, you can set what priority you want that warning to take on. So let's check out what JLC's manufacturing capabilities actually are. So we'll go to rigid PCB here, so that's what we're working with. And we are going to look for our first item, which is our minimum clearance between copper. So let's keep looking. It's generally going to be something like 5 mil. Okay, so it depends on the copper thickness on the exterior or interior of the board. So let's see, and the actual board technology you're using. So since we're using an 8-layer board, and typically you'll be using a 4-layer board nowadays, we will say that our trace width and spacing at minimum is 3.5 mil. The cool thing about KiCad is if you type in a value in mil, it will automatically convert it to whatever units you're using. So that's a really nice thing to have. You can also do some math. So let's say we wanted it to be 3.5 divided by 2 mil. We'll also do that in the text box. Let's go ahead and set that to 3.5 mil. And these are the minimums. If you find that you don't want to butt up against the minimums, well, it's sort of what your predefined sizes here are for. So I would typically use something closer to a 5 mil. This might be a 6 mil trace. I typically work in metric. Our minimum connection width will also share this value with the track width. So we'll go ahead and copy and paste that here. Let's see if there's anything else that really applies here to the copper. Nope. We'll go and check on our via sizes. So our plated through-hole annular ring, let's make sure there's nothing else. Oh, we'll go ahead and grab this since we see it via hole to track. Copper to hole 0.2. Okay, excellent. And we'll keep looking. Do they have anything specifically? A section on vias. Okay, took me a second to find it. Min via hole size and diameter. This isn't listed in a place that's easy to find, but you will see an additional charge for smaller via sizes. You can see go up, it's an extra $30 and a little bit less as you go up, extra $50 as compared to the base price. So this really just depends on what you find you need. So when you start your project and you know the density, the pitch of whatever tiny ball grid array part or something you're using, this would be a good time to check the price difference between those items. So we'll go ahead and use these settings at 0.45 millimeters, and we need to do a little bit of math. It's 0.3 millimeter drill, 0.45, let's do 0.45 minus 0.3 divided by 2. It'll calculate that for me. I'm going to beef that up, just do 0.1 millimeters as the annular width. Copper to hole clearance, we've already checked. Copper to edge clearance, let's see if they have anything to say on that. That is fine. Let's also make sure we catch what our minimum through hole size is, which is 0.3, so that is the same. Now our hole to hole clearance. Hole to hole spacing 0.2 millimeters, so even better than the default. You won't use micro vias when you're working with JLC PCB. They don't support them. So don't worry about this unless you're doing something a little more exotic. So we'll set it here in our net classes. In general, you don't need to butt up against the absolute maximum that your board house can do. So in this case, I'm just going to set these to 5 mil and 5 mil via size. Our via hole, which is what they spec. We actually need to make this via a little bit larger. 0.5 millimeters. And we are good to go. This DP width and DP gap is for a differential pair. These last two items are for differential pairs, the differential pair width and differential pair gap. Really, you would create a special net class for this. So I'm going to leave these with the default values. So now let's run our design rules check. Report all errors and run DRC. Now we're likely to get a ton of DRC errors just because we have these castellated edges. So I'm going to go through and ignore some of these, and then we'll go through the rest. All right, so I've cleaned up those spurious DRC errors, and now we can dig into knocking out some of the larger sets of errors that we're seeing here. There are a ton of these min spoke count errors, and this applies to the thermal relief you'd see on these filled zones. Quick fix for this is to go into your board setup, design rules, and in your zone fill strategy here, change the minimum thermal relief spoke count to 1. This should be acceptable. I would check case by case if you need a different grounding scheme. We'll go ahead and set that. So after I've checked those off, we can see we actually did find an error. So this is what you get when you don't run DRC. See this hole right here is very close to this VBus trace. We're just going to drag this guy out of the way a little bit and align it up so it looks nice heading into this VBus pad. There we go. We've saved the world there, kept this trace far enough away from this hole that it won't fail during fabrication. In a future video, I hope to show you these boards working, maybe with this trace scraped up and tacked together, but working nonetheless. And now with those things changed, you can see that we have very few warnings remaining and no errors remaining in our DRC. Now let's get to setting up our job set to get repeatable outputs from this KiCad source. To create a job set, click File and New Job Set File. We'll name this Job Set Template so that you could possibly reuse this in some other projects. What you'll be greeted with here is the Editor tab and then the Job Set tab. So you could have multiple job sets actually. If you had a job set where you wanted to export one to PCBWay and one to JLC PCB or some other fab and they have different requirements for what files they can take, you could set these up here. Let's go ahead and add our first item. You can filter the items here, the different job types. There aren't that many of them. We'll go ahead and add, to begin with, ERC and DRC to our out job. So our output file, you can set an output file and it will give you a report. So we'll just say drc.log, something like that. Excuse me, erc.log. And you can report a job failure when violations are present. So I think we're going to go ahead and do that on errors only. So if we see a warning that we haven't yet excluded, that's fine, but we will fail on an error. Go back to our job set. So we performed ERC. Let's next perform DRC. Instead of trying to find it myself, type it in here. We'll have drc.log. And we will similarly only fail on errors. Report a job failure when violations are present. Report all errors for each track. Let's just do one error per track. And we will test for parity between the two. Perform ERC, perform DRC. And now from this point on, after we've passed ERC and DRC, as we set up in the job settings, anything we put out will have at least some confirmation that it is going to, 1, fab correctly, and 2, work correctly. Now let's add some nice to have outputs from this project. A lot of the time you'll want to include a schematic PDF with your output files, either for an open source project or for internal consumption. Let's go ahead and click Export PDF. You'll see on a lot of these files, you have to provide some sort of name for them, which leads me to EE schema text variables that can expand in your output jobs here. So you could add something like company, current date, file name, file path, project name without a file extension. And this will actually expand in this output file field here. So we'll go ahead and set up project name PDF. We'll export with our project name, which in this case is this Pro Micro. You can also choose to set the page size, color. I prefer my favorite theme, Witch Hazel. Plot background color, and we will hit OK. That's been added. Any other things we want to export from the schematic? Now, this is a whole nother topic, but formatting your BOM correctly and then generating it would be something you might want to include. That's a topic for another time. It can get quite complicated and will vary depending on which manufacturing house you're working with. So this is sort of a per project sort of configuration. So I'll leave it out at this time. Now, the outputs from your PCB, typically what many board houses support are Gerbers. So this is what I'm going to be doing. You should check with your board house to see if they support ODB++, which I've heard is a nicer format to work with and it's more exact. But regardless, go ahead and export Gerbers. The layers you'll want to include are all of your copper layers. So this will vary depending on how many layers you've actually designed your board with. Maybe 2. Could be, I think JLC supports up to 32. So we will select these layers. Select all copper layers is right here. If you're using adhesive, you'd select this, but I am not, so I'll select front and back paste in case I'm making it stencil, front and back silk screen, front and back mask. And then if I happen to have any comments or drawings, I would also include these here so that the board house can follow them. If I've specified something like V-score or edge plating or stiffener under an FPC, I would include these here. I'll include our edge cuts, and then our front and back fab layers. These aren't critical, and you should make sure these are cleaned up if you're doing something with a pick and place machine where you're actually getting a PCBA out of your fab and not just a PCB, just so they can see the positions of components and the values of the components. Just another place to put them. We will hide D&P here, and then I would always check to see what exactly your board house wants you to include, what format they expect, but the defaults work just fine for JLC, so I'm going to go ahead and click OK. And now we will include our drill data so they know what size and where to drill the vias that are going into your board. I've also found that the default settings here work just fine, but you could also be sure double check by generating a map as well that JLC or whatever board house can look at. And then this is also nice to have, is the ability to export a 3D model so that you can load this into whatever CAD software you have if you are creating an enclosure for something. So just like before, we'll use that variable, which was project name. They've recently added in KiCad 9 a lot of nice features if you're doing something with a 3D model from your board. So you can cut the vias in the board body, export the conductors, so tracks and vias, and then you can do some simulation stuff with those 3D files. I'm not doing that today, so we're going to hit OK from here. So now that you've created your job set, you'll go over here to create an output and specify what it will look like. Typically, I would just select archive. This is what JLC will accept. You could also create a folder and then view your Gerbers and other output material after it's been created, just to confirm that everything looks right. So we'll set our output path here to Kai project mod / project name.zip and then generate. Now, if we go over here, open directory and file explorer, see here we have in a zip file all of our outputs. And now we have created a template that we can use on all of our projects to ensure that we get a repeatable output every time from our KiCad source. I've added this Jobset template to a public GitHub repository, so if you're interested in including it into your project, you can click this green button here where it says code and download a zip, and then include this KiCad Jobset file and any KiCad project you choose to use it on. To use this Jobset template, copy to your project directory and click File, Open Jobset File, just like this. If you liked the video, give it a like, be sure to subscribe to see more, and share with anybody you think might be interested. Thanks.